Making a CPU, central processing unit, from scratch is an incredibly complex and highly specialized task that typically requires the resources of a semiconductor manufacturing facility. It's not something that can be done by an individual or in a home setting. Here's a very simplified overview of the steps involved in making a CPU. Design. **CPU design is a complex process that involves designing the architecture, instruction set, and microarchitecture of the processor. This is typically done by teams of engineers with extensive knowledge in computer architecture and electrical engineering. Fabrication. The actual fabrication of a CPU is carried out in a semiconductor manufacturing facility, also known as a fab. This involves using specialized equipment to etch intricate patterns onto a silicon wafer. This process is known as photolithography. 3. Materials. Silicon is the primary material used in CPU fabrication. The silicon wafer is layered with various materials, including insulators and conductors, to create the complex circuitry of the CPU. Etching and doping. The silicon wafer is exposed to various chemicals and high-precision etching processes to create the transistors and interconnections on the CPU. Doping with specific elements is used to control the conductivity of different regions in the silicon. 5. Testing. Throughout the manufacturing process, CPUs are rigorously tested for defects and functionality. Defective units are discarded. 6. Packaging. After manufacturing, the CPU is packaged, which involves placing it in a protective casing with pins or pads for connection to a computer motherboard. 7. Quality control. CPUs go through extensive quality control processes to ensure they meet specifications and perform reliably. 8. Distribution. Once CPUs pass quality control, they are distributed to computer manufacturers or retailers. As an individual, it is not practical or feasible to make a CPU from scratch due to the specialized equipment, knowledge, and resources required. If you are interested in working with CPUs, you might consider studying computer engineering or electrical engineering to learn more about their design and functionality.